Hey everyone, and welcome back to the channel. As a doctor, I spend my days looking at human anatomy. I've always been fascinated by how different, and sometimes surprisingly similar, the animal kingdom is. So today, we're swapping the clinic for the great outdoors and taking a trip to the zoo. I'm going to be looking at these incredible creatures through a medical lens. What can we learn about their health, their biology, and maybe even our own? Let's go. First stop, the primate enclosure. Look at this. Chimpanzee. It's incredible how similar their skeletal structure is to ours. They have opposable thumbs. Who's like we do, which is why they're so good at using tools. From a doctor's perspective, their social structures are fascinating too. They groom each other, which isn't just about cleanliness. It's a social behavior that reduces stress. It's like their version of a friendly chat or a supportive hug, which we know is crucial for human mental health as well. It's a great reminder that connection and community are vital for well-being across species. Now, let's head over to see the giraffes. You have to wonder, how do they not pass out with a neck that long? It's a question of blood pressure. A giraffe's heart is a 2-foot-long, 25-pound powerhouse. It has to be that strong to pump blood all the way up that long neck to the brain. To handle that incredible pressure, the artery walls in their necks and legs are extremely thick and elastic. They also have a complex system of valves in their neck veins, called the rete mirabile, which controls blood flow when they bend down to drink. If humans had blood pressure like that, we'd be in serious trouble. It's an amazing feat of cardiovascular engineering. Over here, we have the reptile house. Let's talk about snakes. One of the most medically relevant things about snakes, of course, is their venom. Venom is a highly complex cocktail of proteins and enzymes. While it can be dangerous, it's also a treasure trove for medicine. For example, certain components of snake venom that affect blood clotting have been used to develop powerful blood pressure medications, like captopril, which has saved countless human lives. It's a perfect example of how studying nature, even its most dangerous aspects, can lead to groundbreaking medical discoveries. It's all about understanding the biological mechanism. Let's check out the big cats. Look at the power in that tiger's legs as it paces. The muscular anatomy is just phenomenal. Tigers are obligate carnivores, meaning their diet is entirely meat. Their digestive system is short and acidic, perfectly designed to efficiently break down protein and kill harmful bacteria in raw meat. Compare that to our much longer digestive tracts, which are designed to handle a more varied diet of plants and meat. This dietary specialization highlights why nutrition is so specific to the species. A diet that keeps a tiger healthy would be disastrous for us, and vice versa. Now, for something completely different. The penguins. Watching them waddle on land, you might not think they're very athletic. But in the water, they are incredibly graceful. They have solid, dense bones, unlike the hollow bones of flying birds. This helps them dive deep into the water without being too buoyant. It's a brilliant adaptation. Also, let's talk about staying warm. They have a thick layer of blubber for insulation and tightly packed, waterproof feathers. On top of that, they have a special circulatory system in their feet, a heat exchange system that prevents them from losing too much body heat to the cold ice. It's a lesson in thermoregulation. Here we are at the elephant enclosure. Elephants are just magnificent. One fascinating medical aspect is their surprisingly low rate of cancer. With so many more cells than humans, you'd statistically expect them to have a much higher cancer risk. This is known as Patus paradox. Let's look at the bears. Right now, this one is active, but for a large part of the year, they hibernate. Hibernation is a medical marvel. Their heart rate, breathing, and metabolism slowed down dramatically. They don't eat or drink for months, yet they don't suffer from muscle atrophy or bone density loss like a human would if they were bedridden for that long. Their bodies have a unique ability to recycle waste products into proteins to maintain muscle mass. Imagine if we could replicate that for astronauts on long space journeys or for patients recovering from major illnesses. The potential applications are mind-blowing. Finally, let's visit the aviary and look at these parrots. Their respiratory system is incredibly efficient. Unlike us, where air flows in and out of our lungs, birds have a one-way system. Air flows through a series of air sacs and into the lungs, meaning they get a constant supply of fresh oxygen. This is one of the reasons they can sustain the high metabolic demands of flight, even at high altitudes where oxygen is thin. Our own respiratory system, with its in and out tidal breathing, is much less efficient by comparison. It's a completely different, and in many ways superior, design for their specific needs. What an incredible day. Seeing these animals up close really puts our own human biology into perspective. From the giraffe's cardiovascular system to the elephant's cancer resistance. There's so much we can learn. It reinforces how interconnected life is, and how studying the health and biology of the animal kingdom can directly benefit human medicine. Every creature has a unique set of solutions to the challenges of life. Thanks so much for joining me on this medical tour of the zoo. It's been a blast, combining my passion for medicine with my love for animals. I hope you found it as fascinating as I did. If you enjoyed this video, please give it a thumbs up. And don't forget to subscribe and hit that notification bell so you don't miss our next adventure. See you in the next one.